Hello, welcome to our panel discussion today titled Three Dimensions Converge on Smart Manufacturing. We have a great panel and a topic of strategic importance to achieving the next generation of manufacturing ecosystems. We hope that this discussion will help your organization with future plans, roadmap, and discussions on this complex topic, and help you with the journey ahead to smart manufacturing. First, we must thank our sponsors. Members and sponsors allow us to provide these types of materials and presentations. They help us develop the body of knowledge and keep Mesa International going as a vital resource in the industry. The panel discussion today and the related paper are examples of how manufacturers, vendors, system integrators, and educators come together at Mesa International to move the manufacturing IT landscape forward for the entire industry. Our agenda today includes the three dimensions for smart manufacturing with examples. The inspiration for this presentation is a recently published white paper from Mesa with the same title, Three Functional Dimensions Converge on Smart Manufacturing. We will give you the link to that resource and others at the end of the webcast. As we dive into these topics, we will be discussing examples beyond the ones in the paper to help illustrate the relations and integration opportunity among all these three dimensions: digital thread, smart factory, and value chain. I am Conrad Leyva, VP Product Strategy and Alliances at iBaseT, and Chair of the Smart Manufacturing Working Group at Mesa International. My work recently with aerospace and defense companies has focused on smart manufacturing, intelligence, and the digital thread between engineering, business, manufacturing, and sustainment systems, working with partners in PLM, ERP, and factory automation. I am joined today by two subject matter experts with decades of experience in a variety of manufacturing industries. Jimmy Asher is Executive VP Manufacturing Transformation at Mesa International. He has spent his career in the industrial automation and software space as a practitioner, consultant, and software leader in a variety of industry segments. He is currently working on Mesa's program of education and assessment for manufacturers. Stu Johnson is Director of Product Marketing at Flex. Stu has more than 25 years of experience in the manufacturing industry, including enterprise systems for manufacturers in the consumer, aerospace, automotive, and heavy equipment industries. He currently focuses on the future of integrated software for smart manufacturing. We're planning to have a Q&A session towards the end of the webcast. In order to participate, you will need to use the Q&A feature in GoToMeeting. Today's presentation is being recorded and will be posted along with the slides at Mesa's resource library. So let's get started with our topic today. Whether we call it digital manufacturing, Industry 4.0, or smart manufacturing, the scope of smart manufacturing is very ambitious indeed. Mesa defines smart manufacturing as the intelligent real-time orchestration and optimization of business, physical, and digital processes within factories and across the entire value chain. Resources and processes automated, integrated, monitored, and continuously evaluated based on all available information as close to real-time as possible. But what is different about smart manufacturing compared to the last few decades of automation? Because after all, automation, integration, real-time sounds like things we've been doing for a while. What is different is that we're talking about a much, much higher level of connectivity. And we're talking about doing that across the entire value chain. We're going beyond the old hierarchical models, like the ISO 95 model. We're leveraging technologies like wireless, mobile, artificial intelligence, cloud, and edge computing to achieve much higher levels of automation and connectivity. For example, NIST did a study of data movement in smart manufacturing and concluded that the old model was too constraining for this new, highly connected world. NIST believes that we're moving to a network of intense digital communication in all types of directions in the future of manufacturing, forming a complex digital tapestry. And believe me, that's a good thing, not a bad thing. It seems like a difficult thing, but we're going to make it easier. By organizing this network of communications into 3 dimensions: digital thread, smart factory, and value chain. Dimensions that help us organize, explore, and explain these initiatives and understand the pull from each of these stakeholders' perspective on the transformation. We will discuss each of these dimensions right after we do a quick poll. And this is going to be a multiple choice poll. And your first time to participate. So please let us know which type of initiatives are part of your smart manufacturing journey in your company. What are the kinds of things you are working on today? Okay, I will give you a minute to do that. And while you're doing that, I'll let you know a little tidbit here. I recently read an article that Accenture surveyed manufacturers and showed that 68% of executives believed that they had to work on digital transformation, but only 16% had a roadmap, a definite plan, and only 2% were executing to their plans. So at Mesa, we're developing tools like these to help you develop those plans, to create your roadmap, to move forward. So let me see, I'm going to close the poll. Thanks for sharing, and let's see what we have. So what we have is that IoT, smart factory, is really the dimension that is getting most work done, but we still have a considerable amount of people working on digital thread and on the supply chain dimension. You know, it's very often, like Gartner's reported, that the supply chain is being worked independently of these dimensions in the factory. But at some point, the manufacturers that really get these dimensions together are going to be the leaders of the future ecosystems. So let me move on. Thanks for participating in that poll. We're moving together here. So now it's time to start drilling into each of these dimensions, and we'll start with Stu talking about the digital thread dimension. Go ahead, Stu, please.
Thanks, Conrad. You know, having started my career in product development companies, both large and small, I think the digital thread is enabling so many more opportunities to streamline processes and eliminate all the repetitive, manual, paper-based processes. It's just time-consuming, error-prone, and frankly, just not value-add. Now, I like this graphic, although it's kind of rudimentary, but it effectively represents the process to define and produce a product. But you can imagine the other half of the equation, or the diagram much like this, that happens when you sell products, especially those that have, you know, to be supported through maintenance or warranty. But I think one of the most important elements of digital thread is that concept of the repeatability, right? Digital transformation, especially with the addition of IoT, enables all our smart products to report back on their usage, giving product makers a lot more feedback on how to improve their products. Next slide. Now, I think it's important to set the scope of my remarks today on how the digital thread enables smart manufacturing. We can do a whole session just on digital thread. But the point I want to make today is that we're on a journey, right? A transformation between the old way and the new ways that all these digital technologies are providing us. And as quickly as we streamline and automate, products and processes are getting even more complex. So at a minimum, the front end of the process is about populating that digital thread with, you know, voice of the customer requirements, what the product's supposed to do, that are then translated into design specifications, cascaded into functional requirements. And of course, in order to produce a product that's fit for purpose, right, we need to translate those specs into quality requirements, checks to validate that we're producing against the spec. And of course, we always have the ever-present compliance requirements from industry, government, customers. But this job has become much easier to digitize with modern CAD and PDM, the model-based design. That's what MBD stands for in that acronym. That allows us to capture and document the requirements as data entities in the model, and then manage how the design satisfies those requirements. In fact, CAD and CAM systems have become very robust in terms of defining that overall product and digitizing the processes to produce them. But we still see every day manufacturers who are still translating all their digital definition files, like CAD models, into paper documents like drawings and work instructions for execution. And I think there's a lot of opportunity for improvement in extending the digital thread through production operations. And Conrad will talk about that in the Smart Factory bit. But when we translate into a digitized operational system like MES, we tend to lose associativity between the model and all the subsequent operations against that model. For example, I think we're getting much better at managing and documenting production quality. And we've had digital test systems and librarians for decades. But there's still a lot of translation and duplication of data as it goes from CAD to CAM to MES and into QMS. And I submit that might explain this continuous increase in product recalls. Even though we still have quality compliance, kind of always just right along as a check in the box. But the after-sales service component, I think, has a lot of opportunity for enhancement as well. Next slide. Again, this digital foundation of CAD can help us document, as-builts and produce service manuals. And engineering against a digital model can simulate how and when products may need to be serviced. But I wonder, are we at a point today where we can actually say we're improving on warranty claims? And our lessons learned from customers and service being captured, effectively fed back into the actual life cycle of the product. Are we closing the loop? Because what happens in this diagram if a change occurs, right? All of these handoffs, all of the processes need to be repeated, and somehow documentation needs to keep up to date. So one of the things that's missing, in my opinion, is a common platform upon which to store, communicate, and archive all the data to facilitate all these necessary processes for both product development and manufacturing, for the complete life cycle of the product. Although I spent most of my career in PLM, I don't think we're there yet. Because between PLM, which is fundamentally an iterative platform that acts as a system of record up to release manufacturing, and ERP, which is a transactional-based system of record from then on, it's challenging to keep all these data streams moving. And then within and frankly crossing over both these two is manufacturing execution, or MES. Now, as Conrad mentioned, S95 tried to reconcile all the data communication requirements, at least between the floor, MES, and ERP, but I agree with NIST that it's an old model and it's just not robust enough for today. And then now we have new CRM systems like Salesforce, Salesforce.com getting into the fray, positioning as the repository for all the Internet of Things data, the smart products data. So now you got new crossovers between IoT and CRM. And again, all this is fine because each domain has different needs. But the point is the data I described in that previous slide has to somehow find its way from start to finish and hopefully repeat. And it's not like these silos can't be connected, because they can be, and they are being every day. I think many companies will call themselves model-based enterprises when they've effectively done this. But the integrations are far from simple, and there are just too many different formats to convert from one domain to the next. And this was the point of an earlier white paper from Mesa regarding smart manufacturing, the landscape explained. Because I think what's missing is that common schema for cradle to grave. And although the Venn diagram doesn't really capture the complexity of the challenge, this connected enterprise system with operational execution at the center is, I think, what we're really looking for and what the paper describes. So again, I think NIST is probably closer to reality than anyone else, but I always envisioned the digital thread as this flow from left to right, where the business has its need to sell a product to make revenue. R&D puts forth definition of the product to satisfy market requirements. Supply chain, consumes those characteristics and often is contributing back as, engineering partners. Production execution has to extract functional requirements and then add back the actual performance against those requirements. Service is leveraging manufacturing and maintenance requirements and understanding the mechanical functionality so they can hopefully sort through why a solution failed. And again, adding on the new IoT to give us this closed loop of performance information that can help go back into the process and, wash, rinse, repeat, right? Because I think the biggest value of repeatability and having this data model is to eliminate manual paper-based movement of data with the network data that, when a change occurs, it's easy enough for the database to adapt. So, I think the future will be a network of data points connecting to and referencing each other as appropriate to the task at hand. It'll need to be in a common database or at least a network of interconnected database. I think it's more realistic. And frankly, the only viable platform for such a network is cloud or interconnected network of clouds. But having such a data model, I think is going to be the key to effectively repeat without, dropping critical bits from one model year to the next. But I want to close with an example from one of my customers, Gen Z Scooters, a truly connected product, a smart scooter. They've got sensors and telematics throughout them designed in that constantly communicate with their data center. They send signals on the health of the vehicle, usage patterns, fault situations, and at any time Gen Z knows where these scooters are, they often sell to fleets, how much charge is left on them, and the speed they're traveling. And all of these signals for each consumer are combined and stored with the VIN number in their Plex manufacturing cloud, along with all the service history and all the after-sales service management. It's a beautiful example of the Internet of Things, going beyond the four walls and bringing data back in. But Gen Z uses the learning from these signals to impact future designs. In fact, they're considering scooter as a service to price by the miles rather than upfront. And then they can plan their lucrative service and maintenance business around that new revenue model. And of course, they've created their own closed loop digital thread by integrating their design systems with their execution systems and the business systems. And one of their biggest challenges is they source materials and components from suppliers and partners all over the world, which sets up a pretty challenging value chain problem, which I think is the perfect segue to hand over to Jimmy to talk about the value chain management dimension of smart manufacturing.
All right, so Jimmy, can you tell us more about the value chain dimension?
Sure. The value chain dimension extends the natural lean manufacturing principles of eliminating waste. I believe that most know that traditional lean focuses on the principles and the physical manufacturing process. By that I mean the transformation of materials inside of the products, inside of the factory. The extension is the incorporation of eliminating waste related to the digital handover of data along the value chain. And that goes beyond the internal into external resources as well. In today's landscape, the manufacturing plants are becoming much more in tune with the demands and needs of their upstream and downstream components. In the graphic, you could see the interplay between the different management facets: suppliers, resource, operations, compliance, and customers. Today, most manufacturers are assembling products where over 50% of materials and components come from the supply chain. We need to view each of those physical plants as nodes in a multi-tier value chain, an interconnected web, if you will. The desire for manufacturing is an end-to-end system with configurable, repeatable activities, all with an eye towards real-time transparency. This means that each node is exchanging data with the other, We must greatly improve these lines of digital communication, moving from emails and phone calls to a truly set of digital threaded workflows with our value chain partners. One example that I like to share is in the food industry. When you think about it, food is a product of chemistry, yet its makeup is completely dynamic and changing. The ingredients themselves are changing. Working our way back from the customer packaged good, in this example for the yogurt and cookies, we could think about the various nodes in the supply chain, from the warehousing used to stock the end products to the manufacturing plant where they are assembled, and in this case, mixed, and farther back, the fields and the dairies that raw ingredients are collected from. The interesting thing is that cows do not produce milk the same. Their breed, age, environment, and diet can alter the milk itself. While we might think of some elements like taste, the fat and protein content vary as well. These are the elemental makeups of cookies and yogurt. Now, in the case of our yogurt manufacturer, how do they account for this? They need a consistent level of fat and protein to get a consistent product. Oftentimes, blending is used to ensure that you have a baseline consistency, mixing different milk sources together, either through the co-op or at the factory itself. But sometimes that might not yield optimal results. In the case of the manufacturer, we'll use condensed milk to boost levels, requiring a surge in the supply chain or an alteration of the manufacturing process itself. It should be also noted that products that we're dealing with have a fixed shelf life. That's to say they have an expiry, so mass inventory isn't the best option either. With smart manufacturing, we can leverage data payloads that were mentioned earlier from the digital thread dimension and overlay those onto the value chain. This creates a process to inform, predict, and control shifts in demand, and will in turn drive profits and transparency. While the example that I stated seems straightforward, you're dealing with an entire network of vendors, manufacturers, from farmers, co-ops, to co-manufacturers, manufacturers, distribution, and finally consumers themselves. So in the example I just outlined and focused on operations, you could see how compliance and customer management might be affected as well, all parts of the value chain. Now, Conrad, how about you take us to the last dimension for smart manufacturing discussion?
Okay, thank you, Jimmy. As you mentioned, each plant, each factory is a node in a multi-level value chain. That means that each factory node needs to be ready to participate in this new era of real-time digital data exchange in that value chain. The smart factory dimension is therefore very important because data is only going to move across the value chain as fast as the slowest link in the chain. This dimension can also be referred to as the industrial IoT dimension, with the goal to connect factory resources to gather data directly from equipment as close to real time as possible. Data that needs to get contextualized and analyzed at different aggregation levels. Data that triggers immediate response to situations requiring attention, from adjusting machine settings to modifying the normal routings to accommodate a machine downtime. Data is passed to each level for different types of analysis, not necessarily serially. Actually, it should probably be in parallel so we can achieve processing as close to real time as possible. Data passed to all applicable enterprise systems, including ERP, MES, PLM, and supply chain. And data needs to flow up to business intelligence, where we calculate actionable metrics tied to our corporate goals and KPIs. Acquire, associate, aggregate, analyze, and act. All very important part of this dimension. Each layer has different types of technology, tools, and different type of analysis and visualization. They're all important to the overall system. For example, we might be measuring temperature or pressure of an oven at the lowest data level. At the next level up, we're tracking events like job start and ends, issues holding up production. And at the highest level, we are tracking products completed per day and productivity levels for the entire week. Whenever possible, we want the triggered action to be automatic response. And actually that's becoming more and more practical with the advances in artificial intelligence. But for some cases, we're still going to need to trigger manual actions at the operations management level. So let's look at an example of how the smart factory can come together with an example here at the electronics lab at the UK's Manufacturing Technology Center at Coventry. In this example, a flexible manufacturing cell was set up and configured each machine with the right program for each different board coming down the line. The boards identified by RFID. We used to set up this line for long runs of the same board, but now we can run custom jobs for each different single board coming down the line. We can move to order of quantity 1 because of the efficiency provided by this level of integration and automation between hardware and software vendors, and actually among different vendors of hardware and software. Data is flowing from machines to a machine service bus to an MES, and also in parallel it is being aggregated to display at a graphical dashboard with the current status for each station. If the data collected shows a problem, the conveyor belt diverts the board to a rework station, where we use instructions in augmented reality to fix the board and return it back to the line. There's a lot more to this example, but you can see how data is flowing between machines, software, and business intelligence in the smart factory dimension, and among solutions from different vendors. Easy multi-vendor integration is a key goal for smart manufacturing. The examples so far have been focused on different dimensions, but it is hard to keep examples to just one dimension. The value of this new level of connectivity in smart manufacturing is going to be much greater when we link all these dimensions together. Jimmy, can you talk to us about an example like that crosses the multiple dimensions?
Sure, I'd be delighted to. Perhaps one of the best examples that comes to mind is in the manufacturing of hard drives. As we all know, the computer market has seen explosive growth over the past couple of decades. Along with that growth, there's an evolution taking place. Demands for storage space are also increasing with an ever-increasing smaller footprint. The market has forced the elements that comprise a typical hard drive manufacturer to grow increasingly smaller, now at the nanoscale. At this scale, physical shifts in temperature, vibration, and process layering require material to be deposited in several atoms thickness. It's common to process, measure, but that's very restrictive in throughput. The only way for manufacturing to keep up with demand is for the equipment, or in semiconductor speak, the tools, is to share the downstream information with other tools. This goes beyond traditional optimization and enters a place where both real-time and transactional summary data is used by machine learning algorithms to sweep over the data. To watch, alert, intervene as the processes are optimized and controlled. This requires a smart factory dimension that we just discussed. Also, as we could see from the picture, a hard drive is comprised of many different components, some with direct manufacturer's control and others outsourced. The overall end-to-end manufacturing can span several months. It's important to shift demands and informational payloads in real time between the interconnected factories inside of the supply chain as the demand shifts along with it, and aspects of supplier management, resource, compliance, and ultimately customer management. It's truly a factory comprised of factories. That's the second dimension of value chain management. Also, because of the change in market, there are new products in design emerging every 6 months. Semiconductor tools are expensive. So the data we capture during the manufacturing needs to be fed back into the design process and ultimately govern the specification of key process steps, which was what the first dimension that Stu spoke about, the digital thread. Now I can dive deeper into any one of these specific elements. The key takeaway is that all three dimensions are truly an interplay and drive competitiveness. Conrad, back to you.
All right, thanks for that example. So we have shown you today examples of how to organize your roadmap and discussions into these three dimensions, which correspond to three big pools in the organization: digital threads, smart factory, and value chain. There are other models out there, including this NIST model I'm showing you here. No kidding, that's a real diagram out of a NIST paper on the landscape of standards for smart manufacturing. And I think that ours is a little simpler, but the NIST paper does have a lot of good information on standards and demonstrates how there's a lot of dimensions to this problem. So no doubt about it, this is hard work. The model we discussed today can be a starting point for your organization. The important thing is that you pick a starting point and create the model for your company and the plan for your organization. Then we focus on boxing functions in the value chain and what integration is needed between those functions. So we're focusing on integration versus trying to create one giant system in one box, because we know that pieces of the box are going to have to be replaced, and we want to set up for flexibility in the future. By focusing on integration that is needed in the main functions, we will have a more robust and flexible system for the future. So now comes the more dynamic and participative part of this webcast today, and I'm glad that we actually did our presentation in pretty good time, so we have a lot of time for the Q&A. Use the Q&A panel to enter questions for us, and we will try to pick a few here to answer with the time we have. And if we run out of time, we will defer some questions to get back to you later. So let me see from the questions coming in, what do we have here? Here, one of the questions coming in is, what is the difference between smart manufacturing and Industry 4.0? And I'll go ahead and take that one. In general, we can say that smart manufacturing and Industry 4.0 are actually interchangeable terms. You know, they're top umbrella terms for the current digital transformation in manufacturing. The Industry 4.0 term has two origins. One is referring to the fourth industrial revolution, which actually has not happened yet. The idea is that we're expecting this revolution to happen as a result of the current digital transformation in manufacturing, and we're expecting huge revolutionary levels of productivity in manufacturing, a huge rise. And the second origin of that term comes from the German government initiative that was named Industry 4.0, which has set goals for the advancement of cyber physical systems in manufacturing. Now, based on Mesa's recent experience in a German trade show, we can use smart manufacturing name, and audiences know what we're talking about. So smart manufacturing or Industry 4.0 or digital manufacturing, you can use these terms pretty interchangeably. That's how I feel about it. Okay, let's see other questions coming in. Okay, so here's another one. What is the role of current enterprise systems like ERP and smart manufacturing? How will their role evolve? Stu, can you take that one, please?
Yeah, of course. And I think it's key. I mean, we have to have these systems. They exist to fill their part of the business. But I don't think manufacturers get up in the morning and say, you know what, I need me some ERP or some PLM. It's just these are the domains that exist. And from my diagram, and then even again in the NIST diagram, you can see the tremendous overlap between them. And I think it depends on the system, of course. Our system, for example, is an ERP with MES integrated and designed together. Conrad represents a system, Soluna, that's an MES that has MRO and the service component integrated together. And so there's a lot of people, a lot of different companies trying different combinations. But the net is no system does it all, and they have to be able to be integrated into one another. Again, I think key is understanding the complexity of that and the quote unquote landscape as outlined in the white paper. And something I should probably add to my diagram is the emergence of integration platforms as a service, iPaaS. A couple of brands out there I won't mention necessarily, but that has made this much easier, where each system can define the APIs, gazintas and gazoutas, and then having a common platform that can sort of route the data, translate the data, put it in the right formats. I think that's really going to be the future on how all these systems are allowed and able to talk to each other. And hopefully they'll all merge into that network, that clouded network that NIST laid out. Hopefully that makes sense.
Yeah, it does. Jimmy, would you like to add to that, or we can move to the next question?
I think Stu covered that one. So
okay, here I have one for you. We mentioned several examples, and there was a question here. What types of problems or challenges did we experience in some of these projects? Jimmy, would you like to tackle that one?
Absolutely. So, the typical ones of connectivity and transmission, timing, how quickly the data needs to move, and whether a system's open or closed, were all relevant. But I'd like to go beyond that one and dig a little bit deeper and kind of talk about culture. Anytime that you start getting different organizations together, there's some calibration of the expectations required. And this is only further complicated when you start dealing with organization to organization relationships. So, i.e., manufacturer and vendor or manufacturer and customer. Transparency is oftentimes reluctant. To combat this, I think that we need to ground our conversations and talk about the why, the need and the value. And then these form context. Once that context is referenced as a frame, then the conversations usually begin to open up and flow. And that same context is often helpful in going back to the data conversations and defining the data payloads that were talked about in the connected factory and in the digital thread dimension as well too.
Well, yeah, so the human factor is very important. We need to make sure we are developing these skills that go with the new equipment, new technology, and the digital dexterity that goes with it. Another question here is about legacy systems, legacy equipment. Are we going to need to have a rip and replace type of strategy? And I want to let you know that, for example, even at the Technology Center project, not all equipment was 100% ready to participate in the type of communications we needed. They didn't have necessarily the type of APIs, programming interfaces that we were looking for the type of data exchanges to be able to load programs from the outside. So we actually had to develop a lot of middleware. So that's one strategy. So there's a strategy that you're going to have some legacy systems and equipment that is ready for the new smart manufacturing type of communication, and you're going to need to handle a lot of other equipment with middleware that makes up for it and can convert legacy protocols to newer protocols, and maybe combine multiple data into one transaction for another destination system. And in some cases, yeah, we might need to replace some equipment if it's critical enough and part of that value chain information that we need. It might be worthwhile, all of that. But it shouldn't be the place to start with the rip and replace philosophy. We need to evaluate what are the processes that are most critical to achieve the strategy for your organization. And I've seen a combination of those.
Yeah, let me weigh in on that too, Conrad, because I've spent a career supporting these enterprise systems, and you know, it's pretty standard in the ERP industry, for example. There aren't a lot of big rip and replace for ERP. That's a pretty painful thing. And PLM really is sort of just on the rise. It's you know, obviously been going for 20 years, but is reaching that level of maturity like ERP. So kind of those two bookends I showed on my diagram, you know, are pretty solid. And the vendors are moving everything forward, moving to the cloud, you know, in my vision of the unified cloud. I think the real opportunity is that sort of MES in the middle. I don't know if you noticed the slide I had MES and MOM. I always joke that MES has sort of an identity crisis, right? Or is it an MES or is it a MOM? And that definition is problematic, right? There is no one right definition. I think that part in the middle, especially in your diagram, that connected enterprise system might be driven by the needs of the operational system, the MES, and that might be an ideal core for a smart manufacturing platform to emerge, right? And by design, knowing it needs to connect to all the systems around it. That seems like a viable future for the next 10 or 20 years.
Yeah, and it's important to note that we on purpose, we're not identifying systems like ERP, MES. In our diagrams, we were focusing the discussion on functions. And it might take one, it might take multiple systems to address different functions. But we do believe that the important thing is for organizations to focus on business processes and the functions and how they integrate, and then decide what systems are going to do what, and how to transition to that vision, right? But and another point here, because I have a question that talks about cloud, and I think we might have left the impression that everything needed to move to the cloud based on one of your diagrams, and actually we have a great paper that we put out on cloud strategies and cloud computing for smart manufacturing in the Mesa resource page. And we talk about the possibility of all kinds of combinations of cloud and on-premise, and the role of cloud as a value added, not just as a way to move infrastructure to a more affordable base. It's more of a way to connect things. So I encourage people to go after that paper.
And I would agree with that. You know, moving to cloud for cloud's sake isn't the right move any more than rip and replace for smart manufacturing's sake. There are likely other business challenges or demands that would drive, would contribute to and contribute to that decision, right? That if we need to do this, we need to do that, and by doing this, we get smart manufacturing too, or we can enable smart manufacturing. I think that's the bigger business decision on whether to move or not.
Yeah, I think the point that resonates in my mind is that this is a journey, right? So if you think about the infrastructure, the legacy systems, there's a lot of different systems inside of manufacturing today. Obviously, we're not advocating a full rip and replace across all of those, but rather a piece-by-piece evaluation where you look at the function that they play inside of the manufacturing process or the supply chain, and the data that you need to abstract out of those. And at the same time, asking yourself, what information could allow that process to morph or change, right? And then overlay that with value. And then when you look at those axes, it might mean that some systems are interfaced and used by middleware, some get replaced, some are leveraged in the way they are. But it's a continual journey, and you're finding value in each step of the way.
Continuous improvement.
Great questions coming in here. I got another one here. There was a reference to the IC95 model. Are these standards still relevant, or are there new ones coming for smart manufacturing? I think it's important to recognize that standards are not static. They're continuously evolving. So even the IC95 model is having iterations right now. And there's a lot of work and evolution happening right now with standards and a lot of collaborations among different standard groups motivated by smart manufacturing. And we have a recent paper in a webcast, the paper number 58, The Importance of Standards for Smart Manufacturing. So please look at these resources on the Mesa Smart Manufacturing page. I'm going to provide that link right after the Q&A. So that's another great resource. But a lot of standards are evolving. A lot of groups and different standards groups are collaborating among each other because they have different domain expertise. The ones on the plant and the ones on the supply chain, for example, have been evolving separately and now are talking to each other so they can define handovers of data between their different standards. And NIST is another organization very involved in facilitating that communication. So other resources, let me see what other questions coming in here. Do we foresee IIoT becoming middleware between level 2 and 3? I think when you look at the smart factory dimension and the IIoT, I think it has roles at all kinds of different levels and places in the architecture. So there's the data acquisition side, there's the middleware side, there's the analytical side. There's an analysis is not going to only happen at one of those layers. I hope that message was coming across, that there's analysis, there's in-stream type of analysis that will happen at a time series level and detect certain kinds of problems. And there's analysis happening all the way up at the metrics level to determine trends in our metrics that are not healthy. And we're going to use different tools at different levels and different. You might end up using the same analytical engine, but it's going to definitely be using different algorithms and different rules for analyzing different levels.
But Conrad, I got to tell you, I go to a lot of IoT conferences, and that's a really interesting question because for companies that maybe couldn't spell MES before, I kind of joke, but have the need to manage their execution, people are looking to industrial IoT tools. They give them the connectivity, they give them their sort of recording and added value, more analytics than most MESs would provide. And so I do kind of see that ilk of technology, again, drawn in sort of the center, could smurge more with MES and MOM and enable more of that maybe hub and spoke kind of diagram than the sort of cloud network. But I am hearing people talking about that.
Yeah, great. Yeah, I can see for some people it might become. It was the word middleware that concerned me. Does it necessarily need to be in the middle? Is it a facilitator? Which part? There's quite a bit of technologies under the IoT and industrial IoT umbrellas. So yeah, some of it is more like middleware or communication bridges, and some of it might facilitate like a hub and spoke data transmissions, which I think is very important, that we have more and more parallel communication pipes and pipeline in the future. So
think lowercase middleware versus uppercase middleware, which would be the more formal sort of integration.
Yeah, and Conrad, it looks like there was a question that just popped into the question poll as well too on some overlap to that, and that's around: do you see this connecting technology and optimizing the total supply chain rather than the individual links in the supply chain? And will it be possible to share the benefits with all participants? So obviously we've been talking about the interconnected nature of the data and how supply chain needs to talk to the process before and after it. But some of the concepts inside of IIoT allow that data to spin the relationships more than just the first order, if you will, inside of the link. And you see some synergy starting to occur inside of different companies inside of the supply chain. Now, those conversations are somewhat slow because you get into some logistical aspects that you have to deal with as well too, from the standpoint of, if I start making that data available as a vendor, can someone later in the supply chain who buys from my competitor see how I'm producing my parts as well too, right? So there's some data security and openness concerns that have to be applied to it. But I think it does drive beyond just the first links of parent-child, and does form the entire supply chain. And there's some emerging technologies that will help with that as we go through and kind of put together that digital tapestry.
Yeah, I think you're right, and there's going to be the big brand owners, and there's going to be leaders that are going to be leading the whole ecosystem transformations. And once you start getting that level of participation at a value chain level, is where you're going to get benefits across that ecosystem. And we see simple examples of that in e-commerce today, and we're going to see a lot more in manufacturing in the future. So great questions today. Thanks for participating. I'm really enjoying this webcast, and I hope the audience is also. So I'm going to wrap up by pointing out some resources. And we might get to some of those other questions offline, but I think we answered a lot of them right now. So remember that the white paper covers a lot more than what we covered here. So please visit the Mesa Resource Library. You can go to the resource library here at mesa.org, or look for the Smart Manufacturing page. And at the Smart Manufacturing page, we have tons of resources listed there, including the ones we mentioned today. And we try to consolidate them there, but a lot of the work is there. And we're continuously putting more resources out. So join the community and join Mesa, really. So if you see something, there's a lot of those resources are available to everyone, but a lot of them are for members, and joining is really valuable, and we encourage manufacturers to join the community, and not only to learn, but also to participate in these discussions and be part of moving the industry forward. So thank you. Actively get involved, learn, educate your team, and make your voice heard to help move the industry forward. Thank you. We appreciate your time today. That's all we got today. Thank you.